Welcome chemists and welcome to another episode of Bale's Chemistry. Today we're going to be talking about using combustion data in making Hess cycles. This is AQA Specification 1.4 energetics and can appear on paper 1 or paper 2 of your final exams. If you're liking the video, please remember to hit the thumbs up below. In the last episode, we talked about Hess's law. If you haven't watched the episode, there's a link appearing in the top right now. Go back and watch this bit where we talked about what Hess's law actually means when we're dealing with chemical reactions. So in today's episode, we're talking about the enthalpy of combustion. Now, the enthalpy of combustion is defined as the enthalpy change when 1 mole of a compound reacts fully with oxygen under standard conditions in their standard states. So we can look at an example with methane reacting with oxygen. We've got 1 mole of methane reacting with 2 moles of oxygen to form carbon dioxide and water. In a slightly more complicated example, we've got hydrogen reacting with a half oxygen this time to make water. The reason why we're using a half oxygen is because we only want to react 1 mole of the hydrogen with this equation. If we look at a simple Hess cycle, it's very similar to the one we did for formation in the last episode. So here we have reactants through to products, and we'd put at the bottom the carbon dioxide and water. Now in formation, we put the elements. Here we're putting the products of combustion. Now the only difference here is that rather than the arrows going up from the intermediates to the reactants and the products, they go down. So when we burn the reactants or we burn the products, we form carbon dioxide and water down at the bottom. In all the exam questions, you'll be given the data that you need to answer them. It'll look a little bit like this. You can see all the values are negative because remember, combustion is exothermic, so energy is released from the system. So we'll take a look at a simple Hess cycle here where we've got carbon reacting with hydrogen to form methane. We'll draw the arrows down to the products of combustion. Remember, the arrows go down for combustion rather than up for formation. And then we'll add in the values from the question. Once we've got these, we'll look at our equation this time, which is reactants minus products, which is the other way around to the formation data we were working with on the last episode. We'll substitute the numbers into the equation, remembering to times the value for hydrogen by 2, because we have 2 lots of hydrogen in the reaction, and this gives us minus 83.4 kilojoules per mole. Remember, always add the units. We're going to look at a slightly more complicated example this time, where we react carbon and hydrogen together to form butane. This time we're given the enthalpy for the reaction, but we're asked to work out the enthalpy of combustion for butane. So we'll draw out the Hess cycle like we did in the last example, we'll put the arrows in, and then we'll add the data that we have. We'll then look at the equation, reactants minus products, and then we'll rearrange this equation. So we've got products equals reactants minus overall enthalpy change. Plug the numbers in and get a final answer of minus 2877.1 kilojoules per mole. So there are 5 simple steps to make sure you always get your calculations correct. Step 1 is to write out a Hess cycle, remembering that the arrows for the enthalpy of combustion always go downwards. Step 2 is to identify the enthalpies of combustion from the question and write them next to the arrows. Step 3 is to calculate the total enthalpy of all the reactants, remembering to multiply any values that you need to. Step 4 is to calculate the total enthalpy of all the products, again remembering to multiply any values that you need to. And step 5 is to use the equation delta H equals reactants minus products to work out the overall enthalpy change for the chemical reaction. Just to quickly recap on combustion then, remember that a Hess cycle always shows the alternative route. Combustion is burning 1 mole, so you need to balance the oxygens up, possibly using a half of the diatomic molecule. Arrows representing combustion always go downwards, and the last step is that the equation that you need to use for combustion data is delta H equals reactants minus products. I hope you found today's video useful on using combustion data in Hess cycles. If you've enjoyed it, please hit the thumbs up below. And for more videos on our channel, remember to hit subscribe. Thanks for watching and have a great day.